Okay, so this is where we're going to begin programming to mill our cute little smiley face right here out of our piece of aluminum. And so a couple of considerations. The first thing we want to note is that we've already created a setup for this piece, and that is setting our origin point for our X, Y, and Z axes. And if you're thinking, wait, whoa, how do I do that? I can't remember. We have explained this before in our Haas tabletop mill tutorial series, so you can revisit that for setting the origin. We're just trying to save some time here because we are trying to look into new considerations like we see over here. We're going to be creating a tool pathing program that incorporates 3 tools. This face mill that you see right here, that's 3/8 inch end mill, and then this 1/4 inch end mill. Now, I think it's worth asking, well, like, why would we do this? Why would we want to use multiple mills when it's like, wouldn't you think it's easier to just make a program for one? Why can't we just use this 1/4 inch end mill for everything, you know, to cut out this piece of aluminum? Well, that's because it's actually not a very efficient tool path to try and cut all that material when we could do a lot more in fewer passes with a larger diameter end mill. The same way that if you had to mow 5 acres of grass, you'd much rather have a lawnmower to do it than a weed eater. But if you have a tiny little patch in a corner near your house that you have to get into, well, that's the time when you want to have the weed eater instead of the lawnmower. And this face mill has a very specific purpose itself. It's going to do the first task, which is cleaning up this, as you can probably see here, pretty crooked top part of our piece of material. So I got a nice stock bottom here, but the top is pretty rough. So the face mill is going to come along and clean this off for us. So now that we understand, like, why are we using multiple tools, let's get into how do we actually set this up to incorporate tool changes and whatnot. I've got Mr. Monroig here to help us out. Mr. Monroig, are we going to start out with the adaptive to program for this face mill?
No, we won't use an adaptive toolpath for that. We have a facing operation here under our cam tab, which should also be in the tabletop demonstration, like where to find stuff. So starting out, we're gonna click our face operation, and the first thing we need to do is give it a tool to use. So we click our tool tab up here, find our library. In our libraries, we don't have a facing mill, so we actually have to build the tool real quick. So we have tool type is a face mill.
How did you find that?
Underneath my tool, when I click my tool, it comes into here and we just click new mill tool. Oh, you said
new mill tool. Okay.
Yeah, new mill tool, and we open that up, and your tool type's a face mill. The diameter of our tool is a 2-inch face mill. Our flute length, all this is pretty standard. We don't need to really change it. We're not going to do anything too aggressive as far as our depth of cut or utilizing the side of the cutter at all. We're mainly just wanting the inserts and all that to stay the same. All we need to make sure is that diameter is right. And our tool, this is going to be tool number 1, and use offsets 1 for the length, and whenever it looks for it in our tool library. Don't need to change anything here. Our speeds and feeds, we're going to run this at 2,000 RPMs, and we're going to feed it at 25 inches per minute.
And this is because of the fact that we're cutting through aluminum?
Yes.
Okay.
We could be a little bit more aggressive, but we're going to program this in a more conservative manner.
And I noticed you're accounting for
the number of flutes.
Yep. So he's putting 5 on there because there are 5 teeth on this end.
And the reason that gets affected is if the less flutes that you have, your feed per tooth, which you use in your calculations for your feed rate, varies based on the number of teeth that you have. So we're going to hit OK here. You can see our tool is in our library now. We're going to select that tool. And then it went in here and it changed all of our spindle speeds and feed rates already for us because we put all that in when we built the tool. So the next thing that we're going to do is go to our geometry tab. It already has the default stock selection. It sees the stock that we want to cut there, so we don't need to do anything with that. Your levels here, You can see it's cutting at the top of our finished surface already, our model top in here, so we don't need to make any changes there. We'll go to our passes tab. Your step over, it's gonna use a little less than the diameter of the cutter of a step over, so there's a slight bit of overlap for good cleanup. But since our material size is under 2 inches, it should just do this in one pass unless it offsets. So we might need to make a change after we generate the tool path. And then our linking parameters, the only thing I ever really want to do is I want it to extend before I retract, so it gets off of my part before the tool holder comes up, so it doesn't leave marks on my part. So we're gonna hit OK here and see what our path generates. And there you can see it makes one pass, comes down, across, and up. So that's our facing operation. Now, like Dr. Stratman said, we don't necessarily want to use our face mill to come in here and get rid of all this material. So this is where we're going to utilize our 3/8 end mill and go into an adaptive path. We're going to use 3D milling, not 2D milling. The 3D milling will look at your model and cut only the stock that it detects, and it will not cut into your part. So we're going to do that 3D adaptive. So now that we're in our 3D adaptive, we don't want to use our 2-inch face mill, so we need to go back into our tools. We're going to go down into this inch aluminum library right here. We're going to search flat for a flat end mill, and we want a 3/8 flat end mill, and we are going to select that for our tool. We don't need to change any of our geometry of our cutter. What is there will work just fine. So we have our 3/8 end mill. We're going to bring our RPMs down. We don't want to run 10,000 because our spindle max is 6 on those. We're going to put this at 4,000 RPMs, and we are going to do a cutting feed rate of 60.
How did you determine that cutting feed rate?
So when we're cutting aluminum on a CNC and we have rigid tooling and stuff, we can be a little more aggressive than what we can on a standard Bridgeport. So your normal 3.82 calculation doesn't necessarily get you what you want, because aluminum can be calculated a little bit differently. If you go too slow, your tools are going to load up and they're not
Like
going to
they'll
clear
gunk up with chips.
They're not going to clear. So, and a reason that we go high RPM, high feed rate is because later on when we get to our passes tab, we're going to look at our tool engagement, and it is faster for a machine to cut fast, like run fast RPMs and run fast feed rate, but take a less of a cut, because that tool is not having to slow down so much to get through the part. It's easier on your tool, and it won't have it wear down or break as quickly. So we will ramp up our feed rates here and do a lighter step over so that we can get this done as efficiently as we possibly can.
Okay.
So you can see, like, whenever we put an RPM in there, 4,000, it calculates our surface feed to be 392. So that's like when you're looking at your equation, your 3.82 times your surface feed divided by your diameter. That's the surface feed that it's using to run at 4,000. If we wanted to do like a standard 200 surface feed.
Yeah, that's kind of why I was asking, because I know aluminum set value is 200.
So if you use your surface feed of 200, it's going to put your RPMs in there at like 2,040, which you're going to have to slow your feed rate down. But with aluminum and these cutters that we have today, you can, if you ramp up this value, as long as you put the feed rate in to go with it, the tools can do it, especially in aluminum. If it was steel, we would look at this in a whole different manner. But the fact that it's aluminum,
it makes that okay.
We can be a little bit more aggressive.
Because it's a soft metal.
Yes.
Okay.
So we're gonna, for the sake of this example, we're going to just use 400 or 392, I think is what it was, to get us close to that 4,000 RPM. We're going to feed it 60, and something that's big like machining, while that you can calculate this stuff, it's not exactly a finite thing like you have to do this. Your machine will talk to you. It'll let you know the sounds, that if it's right, if it sounds right, then you can manipulate it at the control. You can speed it up, slow it down if it sounds right or wrong. So we'll go with this for now, and if we need to modify our values at our machine, we can do that later. So we're going to go to our geometry tab, and we don't need to select any contours. It's going to look at our material in our rest machining here, so it's going to see what has been cut here if we change this to from previous operation. So it's going to see previously in this operation that we faced our part, but it's going to see that there was nothing else cut from the stock that we made in our setup.
Yeah, so it can see what work still needs to be done.
So we don't need to set any boundaries or anything like that, because we're wanting it to look at the part and get into the areas that it can. And then our bottom height, we do not want to cut all the way down to our part. We only want to cut to this surface here. So I'm going to change my bottom height to selection, and then I'm going to select this face right here. You see it light up?
Yep, this should be familiar to anyone who's watched our Haas tabletop tutorials.
Yeah, so we select that. We have our selection set there. Now we're going to go to our passes tab, and this is where we're going to look at our optimal load. So our optimal load is basically the amount of engagement that the tool will have in the given part.
Like how much material it's trying to bite off.
How much step over it's, how much it's stepping into the part. So we're going to take this value and we're going to set it at 40 thousandths, because at our RPMs and feed rate, we don't want to do too much because it's going to put a lot of pressure on the tool and could break it. 40 thou is a good amount for a 3/8 cutter to effectively cut. So we're going to go with a 40 thou step over. Our minimum cutting radius is fine, what its default value is. Our maximum roughing step down, we have the flute length to do this all in one pass, so we're going to set it at 0.5 because it can do 0.5. We have enough flute length for it to do 0.5. And then our fine step down we'll leave at 50. And then we're going to keep our radial stock to leave, but turn off our axial stock to leave. And what that means is, we probably explained it in the desktop mill video, radial is stock getting left on the profile of the part, and axial would be any stock getting left on the floor of the part, which we do not want to leave stock on the floor. For this tool, we're not going to mess with our lead-ins and lead-outs. What we have here will be fine. So we're going to leave all of this stuff the same, and we'll revisit this whenever we go to our next tool. So we're going to hit OK to generate our tool path. And there you can see it generated our adaptive path.
Okay, so this is now officially a more complex program than what anyone who's worked through our tutorials before has done, because we now have a tool change in here. I can see in the setup you've created, it says phase 1 and adaptive 1. So the program already knows, as soon as it sees like, okay, I'm running my face program, it's going to automatically jump into that adaptive, and that is going to cause the machine to do a tool change, to put the facing mill away and go grab the 3/8 inch end mill out of that carousel. So that's something that is like auto done by Inventor when it creates its program.
Yes.
So that leaves us just to, well, I guess that leaves us with our 1/4 inch end mill, and it's going to serve a very important purpose, because as we can see, the bigger exterior area the 3/8 end mill can get to very efficiently, but it cannot fit into these little eye holes, because a 3/8 inch end mill is too wide to get into these little 0.33 diameter holes. And so we need something skinnier like this 1/4 inch end mill to do that. So let's get into that final tool change.
So here again, we're going to start off with our adaptive clearing tool path. We're going to go to our tool tab. We will go to our inch aluminum, type in flat again, grab our 1/4 inch, and this one we're gonna run at we'll actually use our 200 surface feet for this because we're gonna be having to helix down into our parts. So we're gonna run a little bit lower RPM, a little bit slower feed rate, maybe about 25 on our feed rate. 2,000s per tooth is okay. And then we're gonna bring our ramp feed rate down to 18 and our plunge down to 10 because we don't want to plunge or ramp too aggressively into our part. We want to make sure the tool has time to cut, and we're going to leave those feed rates the way that they are there. We're going to go to our geometry. Now here we do want to give it some boundaries because we already cut all this profile out here on the outside. We want to stay within these boundaries here. So
Of like the smiley face
of the
circle.
eyes and the mouth. So we're gonna select boundaries. Under selection here, we want to keep the tool inside the boundary, and we're gonna select,
Okay, tool inside boundary, yeah.
select both of the eyes and the mouth of our smiley face. So we want to cut inside these 3 areas. We're gonna let the rest machining see that the previous operations, what has been done, just like we did on the previous one. So we selected previous operations there, and we'll leave everything else the way that it is. Our depth, here we want to do our selection again as well. We want to select our floor of our eyes and mouth.
Which if you orient that to the side, they'd be able to see that actually you've selected a different depth because we're not going all the way down to this edge. We're going to the base of where that eye and mouth are because it's a different depth.
Right. So we have that set. Now we're going to go to our passes. For our optimal load on this, it's a smaller tool, so we want to be less aggressive. We're going to go with a 20 thou engagement on our tool. Our roughing step down, we want that to be, we'll make it 0.25. 1/4 inch is our max step down that we're going to do with this one. Fine step down's fine. Everything here is fine. We're going to turn our axial stock to leave, put that at 0. Radial, we're going to leave 20. And for the time being, we're going to leave all of our lead-ins the way that they are, and we're going to attempt to generate this tool path. So we're going to hit OK here.
Yeah, and this is going to produce an interesting result here that's going to give us a chance to talk about something a little further.
So you see on this profile, on this side over here, there's a little yellow check mark. We can go to this show log, right click on it, go to show log, and we can see it's an empty toolpath. It wasn't able to generate anything. So we're gonna have to troubleshoot this and try to figure out what is causing this. So we can look at, in these pockets, it's gonna want to try to ramp down and helix into these pockets to cut the material away down to the bottom and then open these pockets up. And due to the diameter of them, we have to control the diameter that the ramp is trying to, the circle diameter that it's trying to drive around. So we're gonna open our adaptive path back up and edit it. We're gonna go to our linking tab and we're gonna look at our ramp right here, our ramp lead in. And it's trying to do a helix, and the diameter that it's trying to helix around is 0.2375. So basically what it's saying is, as you can see in these values here, the center of your tool is trying to run around that helix right there, and in doing so, that is going to collide with our stock. So we need to manipulate that diameter and make it smaller so that it can run around that inside that pocket and you won't have engagement on the outside of your tool.
Yeah, and in other words, what you're saying, just to look off this blueprint, is for the engineer who's like, hey, or the machine tool student who's like, hey, I have a 1/4 inch end mill. This thing is 0.33. 1/4 inch is smaller than 0.33. Like, what's the problem? You know, it seems like there shouldn't be any. the issue we're describing here is that your tool is not going to go straight down into that pocket. It's going to be spiraling in like this. And because of the wide sweeping spiral that it's wanting to make, now that 0.25 is actually going to collide outside that 0.33 boundary. And so we need to tighten up that helix so it goes down in a very tight pattern.
Right. So this you kind of might have to plug and play a little bit, try a couple different values. I'm going to start out telling it to drive a 50 thousandths diameter circle, which is pretty tight, but we do have a pretty small surface that we're trying to get into here. So we're going to start off with that. We're going to hit OK and see what we generate. So you can see we have it generated in here and was able to get down into the lower part of the smiley face. It did not generate a tool path in the eyes of the smiley face. So we're gonna have to go back in and try to edit that to see if we can't get that value to work. So we'll go back to our linking. Let's look at all of our stuff. We'll see what it does on a 25. And again, we're having an issue. So in a situation like this, where I know my cutter, over half of my cutter will, if I just ramp around these eyes, half of my cutter will clean that up. So I'm gonna leave this the way it is, and I'm gonna add a 2D contour toolpath here. So
Okay, so we now have our second adaptive, and we're gonna do a 2D contour to get those eyes.
yes. So I'm gonna click this 2D contour. We're gonna use the same tool with the same values set for the feeds
Yeah,
and
and
stuff.
it's already got that 1/4 inch in there because
Yes.
that's what you were most recently
Yes.
using.
And then we're gonna select the 2 circles we wanna drive, which is both of these eyes here.
And I notice on the contour, you're grabbing the bottom of those circles
Yes.
rather than the top.
And the reason we grab the bottom of those circles is because we're gonna machine at the selected contour level. So at the bottom of those eyes is what we wanna, where we wanna machine to for our bottom height. We're going to click our passes here. We're gonna look at everything here that this is all fine. Our feed rate, since we're only roughing here, is going to be left at 25. We're going to check our stock to leave, and we're going to put a 20 thousandths value in our radial, and we'll just go with 0 in our axial. And our linking, we're gonna turn off our lead in transitions and lead out, and we're gonna turn on our ramp. We're gonna put our clearance height at 50 thousandths above our part. Our maximum ramp step down, this is how much it's gonna go in how far down in Z it's gonna go in a 360-degree pass. So we only want it to go about 75 thousandths deep. Just so we're not being too aggressive. We don't want to try to take that all in one fail swoop. So now we're gonna hit OK and look at the toolpath that it generates here. So you can see it holds a really tight spiral, and it's gonna rough out all of this material in these eyes. Similar to what it does on our adaptive path, but the adaptive wants to clear this floor out. There is no floor to clear out. So real quick before we run our, before we set up our finishing contours that we're gonna run, we're gonna go ahead and run our simulation because we wanna see, make sure we're getting everywhere that we want to with all of our tool paths. So we're gonna select our setup one, click simulate. We're gonna turn our stock on over here so we can see this is what our stock is going to look like prior to us cutting.
Yep.
We'll slow down and go ahead and hit play. So here's our face mill coming in and gonna deck the top of our part. Our 3/8 coming in and gonna rough the profile of our part. 1/4 inch end mill, helixing down to open up the smiley face.
I do want to point out, you can really see that stock to leave around the edges where it just left a little bit behind.
Right here, yeah. All right,
so far so good.
so one thing I'm gonna point out here, you can see over here on the sides of the smiley face, we have a pretty good amount of stock left in here. We're gonna go ahead and get in there and modify that value a little bit to try to get in there a little bit better. So we're not leaving so much stock, because that's a good bit of stock for a 1/4 inch to come in and clean up. So I'm gonna go to my adaptive 2 up here. I'm gonna open that up to edit it. And I'm gonna go into my passes. And when I look at this minimum cutting radius right here, this is gonna tell us how far into this radius it can get. And we're gonna change that value to 5 thousandths and see if that gets us a little bit closer. Hit OK. Oh, now it's actually letting us get into our eyes. So by changing that radius down, it's saying that it can get in closer to this wall than what it thought it originally could.
So that makes our contour unnecessary.
So now we're just gonna, for now, we're going to suppress this. We're gonna keep it there, but turn it off so it can't be seen.
Yeah, so essentially like deleting it without actually getting rid of it.
In case we want to use it later, because we might actually, what we'll probably do is just take that 2D contour and make it our finishing contour pass now, and change all of the stuff that we're driving. So I'm gonna run the simulation again real quick. We're gonna skip through our facing and our 3/8 because we liked those tool paths, and we're just going to play our 1/4 inch roughing adaptive path.
And it is getting in there further.
It is getting in there a little bit further. We can deal with that as a cleanup path. We can get by with that. So we have all that roughed in there. We're gonna close this out, our simulation. We're gonna unsuppress our 2D path, and we're going to edit that path, and this is now gonna be our finishing contour path. So again, we're gonna keep all this stuff the way we had it. We're gonna drive these 2 lines down here, and we're gonna add some other ones. And this is where we select the bottoms of these lines, where this comes in handy, because if we look at the side of our part, we're finishing at this depth and at that depth. And so for our machine to know at what depths it needs to cut in our heights tab here, it needs to use the selected contour, so it knows at each of these levels we need to calculate the post to cut at these levels. So we got this set, we don't want to change that. We're going to go to this tab here, we're going to turn off our stock to leave. We're going to, we already have pre-cut sections, so I'm going to add an entry position to my eyes up here at the center of them, so that it comes down and leads in off of that. We'll turn on our lead in and lead out, and leave those, make those 20 thousandths, so we're not going too far. We don't need a vertical lead in. We'll turn our ramp off, and now we're gonna generate this toolpath and see what we have. So you can see it generated everything that we needed it to. Now this is a 2D contour, so we need to go through. It's not necessarily looking at the model, it's only looking at the lines you tell it to look at. So we're gonna simulate everything and make sure our tool paths are good. So we know our adaptives are good, so I'm gonna skip over these first 3 paths. We wanna verify our contour. So I'm gonna hit play, and you can see it just comes down next to the part, doesn't collide, and does a nice cut finish. All those surfaces are good, and last our profile. And there we have a finished part.
Awesome. So now that we have this, our next video, we're gonna talk about actually like posting this for the mill, and then we'll worry about loading up the tools and doing all those next steps.
Yes.